I have written some of the laws of log. These are the laws of log which we are using for doing logarithmic differentiation. In all the logs, I have put the base a. Okay. And if the base is not mentioned, as I have told you earlier, the base must be e. You will see log with a base e is called natural log, and in various books you will see the notation used is ln for it. Okay. But over here we are using log only, and if the base is e, it is not mentioned. So you understand, it is log with the base e. Okay. So see some of the questions we will take today. This is the one. We have y entirely in terms of x. It is sum of two functions. And when you look at these two functions, they are in exponential form where their bases are also variable and their exponents are also variable. Okay, this you can see. So in such kind of cases, there is a need of using laws of log to simplify it and then go for differentiation. So you can see what I have done, because we can define log of product of two numbers. We cannot define log of sum of two numbers. Okay. So what I need to do, these two parts are needed to be differentiated separately. So we are using the substitution. U is taken as x plus 1 over x to the power x, and the second part I have used the substitution v for it. So our equation is now reducing to y is equal to u plus v. So this is our new equation. Now when we differentiate y with respect to x, we get dy over dx, and on the right side derivative of u will become du over dx and derivative of v will become dv over dx. Now we start with the differentiation part. So this we will solve separately. We will find its derivative, even this one. And then we are going to put their values here in equation 1. That will give us derivative of y with respect to x. Okay. So starting with u. U is sum of x plus 1 over x to the power x. If I take log on both the sides, left hand side becomes log u and the right hand side will be log of this term to the power x. Now over here I have used this third law. It says log m raised to the power n can be written as n log m. So you look at this part, this has got exponent x. So if we use this law, it will reduce to x into log of this number which was written in the base of this term. Okay. So these are two functions, separate functions getting multiplied. So when we go for differentiation now, here we are going to use product rule. So now let us start with differentiation part. So differentiating both sides with respect to x. Now come to the left hand side and see this here. Generally students make mistake. They only write derivative of log u as 1 over u. But see, sometimes they only write du over dx. But see, it is composition of two function. Logarithmic function and u is denoting algebraic function. Okay. So if you see, this is composition of two function. First we will differentiate using the derivative of log, because log x has derivative 1 over x, log u will have derivative 1 over u. But this number is not x, isn't it? This expression, it is u. So its derivative will be du over dx, because differentiation is taking place with respect to x. Now moving on to the right side, you will apply product rule. I am going to do it directly. Suppose I differentiate x. So its derivative is 1. Second part will remain as it is. Okay, now I will keep the first part as it is, that is x, and we are going to differentiate the second part. Again, look at the second part. It is log of a certain function. So its derivative will be 1 over that function and then derivative of this function. So we are applying chain rule here. So this multiplies with the derivative of x plus 1 over x. X has got derivative 1 and 1 over x will have derivative minus 1 over x square. See, this can be assumed as x to the power minus 1, and then you can differentiate it using the formula for derivative of x to the power n. You will see it comes out to be minus 1 over x square. So differentiation is over. We need to do simplification here and write what is du over dx. For that we will cross multiply u. So if I cross multiply u, du over dx will be u times, and what is u? You can put the value of u here. It is x plus 1 over x to the power x. Now this multiplied with the derivative which we have obtained on the right side. So the first part is log x plus 1 over x. Let us solve this part. You will see if I will simplify this part, if I take LCM, this x will come in the numerator. So what do you get? We get x square, x into the x we will get from here. Okay, x square over, and we are taking LCM also here. So it is x square plus 1. Come to this part. Here also you take LCM. We get x square minus 1 over x square. So you can very well see this x square and x square is getting cancelled out. So the second part is x square minus 1 over x square plus 1. So this is du over dx. Once we have found what is dv over dx, we will put both of them here. Okay. Now let us solve for v. V is x raised to the power x plus 1 over x. Apply log on both the sides. We get log v is equal to, I am using the law of log directly here. See, it will be, right hand side will be of the form log m to the power n. So it can be written as n log m. Okay, so the exponent, which was the exponent of this term, that will come in front and it will multiply with log of this base. So I have clubbed two steps. Now we are ready for differentiation. On the right hand side again we will be using product rule. Okay, let us see what we get. Derivative of log v will be 1 over v dv over dx. And on the right hand side, if I keep x plus 1 over x as it is, the derivative of log x will be 1 over x. Okay, so first part of product rule is done. Then plus keep log x as it is and differentiate this. So I am differentiating this part. Just now while finding du over dx, we had differentiated x plus 1 over x. So we saw the derivative was coming out to be 1 minus 1 over x square. And log x we are keeping as it is. Now write for dv over dx. dv over dx will be v we have to cross multiply. And what is v? V is x raised to the power x plus 1 over x. So this times the expression on the right hand side we obtained. Simultaneously simplify it also. See, if I take LCM here, it will be x square plus 1. And we get x in the denominator, which is further getting multiplied with this x in the denominator. So it is x square plus 1 over x square. And this part if we solve, it will be plus x minus 1 over x into log x. So you can see du over dx is obtained and this is dv over dx. So if I mark this one as second equation and this as third, then from second and third the value of du over dx and dv over dx can be put in the first equation. The first equation was dy over dx is equal to du over dx plus dv over dx. So I will write du over dx here, which is x plus 1 over x to the power x, and this is multiplying with log x plus 1 over x and then plus x square minus 1. We could see x square got cancelled out here. So x square minus 1 over x square plus 1. So done with du over dx. Then this is getting added to dv over dx, which we have obtained in the third equation. So x raised to the power x plus 1 over x into x square plus 1 over x square plus x minus 1 over x into log x. So you can see these are quite lengthy solutions, okay, time taking. But if you are doing carefully, then the errors will not take place. A fixed pattern we need to follow here. You can mention for this from equation 1, 2 and 3. Now each question we will be using this method only and will proceed. So few of the steps I have already written to save time. You can see this one, next one. It is again sum of two functions on the right side. Okay, one function is log x whole raised to the power x, and the other one is x to the power log x. So the first one I have replaced with u and the next one I have replaced with v. So y became u plus v. Therefore on differentiating, dy over dx is du over dx plus dv over dx. Then on u we have applied log on both the sides, and using the law of log, the right hand side we have written in simplified form. See, this is log m raised to the power n. So it will become n log m. So the two functions here are x and log x. So I need to use product rule here. Okay, so let us differentiate it. We get 1 over u du over dx, and on applying product rule, if I keep x as it is and differentiate this part, first you will be solving this log, then next log, and then x. So in this order you have to differentiate each. So derivative of log of certain function, it will be 1 over that function. So 1 over log x. Okay. Then coming to the next part, log x. Derivative of log x will be 1 over x. And then derivative of x is 1, so no need to write. So done with this part. Then plus, now keep the second part as it is, differentiate x. Derivative of x is 1 and this will be log of log x. Okay, so differentiation is over. You see here x and x gets eliminated. Now cross multiply u. We get du over dx is equal to u times. U is log x to the power whole raised to the power x. And this multiplies with the expression on the right side. We have 1 over log x plus log of log x. Okay, so du over dx is obtained. Now moving on for v. V is x raised to the power log x. Take log on both the sides. Left hand side will become log v. Right hand side will become log x raised to the power log x. So every time you will see the function after taking log on both the sides, it is reducing to the form log m raised to the power n. And you can write it as n into log m. So we can write this equation as log v is equal to, see this log x will come in front, log x, but then the second function is also log x. So we can write it as log x whole square. Now differentiate. Derivative of log v will be 1 over v dv over dx. On the right side, see at present the base is having variable but the exponent is constant. So it is of the form x to the power n. So using that, if we differentiate it, you will get twice of log x to the power 2 minus 1, which is 1 only. So done with this part, derivative of log x will be 1 over x. So the differentiation is over. If you want, you can write it as log x into log x, and then you can use product rule. That will also give you this only. Okay, now cross multiply v. We get dv over dx is equal to v times, what is v? X to the power log x. This multiplies with 2 log x over x. So this is our third equation giving us dv over dx. So du over dx and dv over dx, we will be putting in the first equation, which is dy over dx. So from 1 we can write, we can say from 1, 2 and 3. Okay, we are clubbing all the three. We get dy over dx is equal to du over dx. This is a big expression. So log x. If, see, I'll tell you one more thing. What else can be done here? If you want, you can take LCM. Okay, this will become log x into log of log x. First term will remain 1 only. So the entire denominator will be log x. You can treat these two terms together then. Okay, this has got base log x, exponent is x. And when this log x will be entirely in the denominator, this log x will have exponent 1. So you can take it to the numerator, and this term can be written as log x whole raised to the power x minus 1. Because whenever two terms with same base are getting divided, we subtract the exponent. And if you don't want to make any change, you can write it as it is also. So 1 over log x plus log of log x. This is du over dx we have written. Then plus dv over dx, which came out to be x to the power log x, and then 2 log x over x. See, they are so large, big questions if you see time taking. Okay, so you need to initiate the question correctly so that your effort doesn't goes waste. So please see, if it is sum of two functions, we cannot apply log directly. I cannot write it log y is equal to log of this term plus log of this term, which is entirely wrong. So we need to separately solve both of them. So again you can see one function is taken as u, another as v. So y becomes sum of u and v. Then dy over dx becomes sum of these two terms. So starting with the derivative of u with respect to x. So this is u. Log u can be written as log of x to the power sin x. Then applying the law of log u will be sin x into log x. Now go for differentiating it. Okay, derivative of log u, 1 over u du over dx. On the right side we are using product rule. So sin x into derivative of log x, which is 1 over x. Then plus log x into derivative of sin x. Derivative of sin x is cos x. So we'll write cos x here. And log x we will keep as it is. So cos x into log x. Now this provides us the derivative of u with respect to x. Cross multiply u. U is x raised to the exponent sin x, and the remaining part sin x over x plus cos x into log x. So done with du over dx. Coming to v. V is sin x with exponent cos x. Apply log on both the sides. We get log v is equal to cos x into log sin x. I have merged two steps here. Directly I have used law of log, the exponent will come in front. So see, even this can be done using the product rule only. So differentiating both the sides. Okay, so derivative of log v, 1 over v dv over dx. On the right side, first I'll keep cos x as it is. We'll differentiate log sin x. So derivative of log is 1 over the function written here. So it will become 1 over sin x. And then sin x also gets differentiated. Derivative of sin x is cos x. So the first part is done. Then we will keep log sin x as it is. Cos x we are differentiating. Derivative of cos x is minus sin x. So minus sin x into log sin x. Okay, so differentiation is over now. You cross multiply v. So dv over dx is equal to v times. That means sin x with exponent cos x getting multiplied with this entire term. It is up to you how do you want to write this product. You can write it as cos square x over sin x. We can prefer to write this as cot x to avoid the denominator. So this will become cot x into cos x minus sin x into log sin x. Okay, now get dy over dx. So therefore dy over dx will be sum of both. So du over dx we will see it was x to the power sin x, and then the term getting multiplied with sin x over x. Even here there is scope for taking LCM. When x will be the common denominator, you can solve these two together also. Okay, or keep it as it is, plus cos x into log x. So this was du over dx, and this gets added to dv over dx, which is sin x to the power cos x multiplying with cot x into cos x minus sin x into log sin x. Okay, so these were few examples you can see which we have done using logarithmic differentiation.